Okay, folks, welcome to Lucky Module number 13, which will actually be the final module of our time together. We're going to be wrapping our mini unit up and wrapping the course up overall. All that'll be left after this is the last quiz, the fifth take-home quiz, any related homework that hasn't been completed, and the final exam. So, first, we start by talking about prediction and regression with a little cartoon here. This may not make any sense to you right now, but hopefully by the end of the module it will, and then maybe it's still not funny, but at least you'll know why it's not funny. So there's that to look forward to. So we'll talk about this idea of extrapolation and how it fits into the framework of prediction a little later on. But first, we'll talk a little bit about some of the basics. So first, we've already talked about the idea of correlations. Again, they describe the relationship between two variables. We can use hypothesis testing to make conclusions about how those variables are related at the population level. But ultimately, what we can do with correlations by themselves is just describe relationships between variables. For example, the relationship between an ACT score and a first-year college GPA. Regression, which we've already introduced, allows us to take that correlation, those relationships one step farther and make predictions. Predict things that we don't know, predict things that haven't happened yet, that are in the future. What we do here is that we take a correlation and we go one step farther, and we've already seen this a few times, by creating what's called a line of best fit. We've got a line of best fit here in this scatter plot behind us, this dotted line. A line of best fit essentially is a way of representing the average relationship between those two variables. In a really strong correlation, the line of best fit will almost connect the dots. There won't be much variability, much deviation from that line of best fit. In a weaker correlation, you'll see much more deviation there. But overall, it models the average linear relationship between two variables. What can we do with that line of best fit? Well, we can take existing relationships and make predictions about things that haven't even happened yet. We can predict first-year GPA from a standardized test math score, for example. And we can get a predicted score. Here we see a Y with a little hat on that. That means it's a predicted Y. It's one we don't actually know. And predict that Jimmy here's first-year GPA should be about 3.22. Will his first-year GPA be exactly 3.22? Probably not. There'll probably be at least a little bit of error there, but on average, our predictions will be quite accurate, and the stronger that initial relationship is, that initial correlation is, the more accurate those predictions will become. So we use relationships between variables to predict a score that we don't know yet, either because we haven't measured it or because it doesn't exist. So predictions are a major part of how people use statistics in the real world. Anytime when you are trying to estimate things that are happening in the future and plan around that, you can sit down and try to intuitively figure things out, but that's pretty inaccurate and biased. Using statistical information is likely to give you more accurate predictions overall. So, for example, college admissions officers do this all the time. They want to know how likely you are to stay in college, to do at least reasonably well, and to keep sending them those sweet, sweet tuition checks. But you haven't started college yet, generally, when you're applying. So one of the things they do is they'll predict your GPA, especially in the first year, based on things like your standardized test scores. Those predictions are imperfect, but on average, they give a pretty good sense of what percentage of students are likely to do well, what percentage are likely to struggle, what percentage are perhaps likely to drop out relatively quickly. Banks use this all the time. When you get a loan from a bank, not everybody gets the same rate. One of the things they do in setting those rates is they use prior information like your income level, like your credit history, all that fun stuff, and they predict how likely it is you're going to repay that loan. And if it's more likely you'll repay it, you get a more favorable rate. If it's less likely, they're going to charge you higher amounts of interest. Similar things with like credit cards. They will set generally higher credit card rates if you are considered more of a credit risk. They're going to hit you up for more interest because, again, there's a greater chance that you'll default. They have to factor that in there. That's a huge part of how bankers, credit card companies, anyone that loans money, that they make their money is by making those predictions and making them accurately. Interestingly, you can even use predictions where the two variables aren't necessarily directly related. For example, you can predict the likelihood someone will have a car accident based on their credit history. People with poor credit history tend to get in more car accidents. There's a correlation there. Now, it's probably not directly caused. It's not that people are like getting depressed about their credit history or they're busy looking it up and they wreck their cars, but Maybe there's a third variable there. Maybe there's a tendency for impulsiveness, where people who have poorer credit history tend to be more impulsive. They spend money without really thinking long term, and they also maybe are more likely to be inattentive or to drive recklessly, etc., etc. Many of you may be familiar with a similar kind of relationship and how it affects your ability to rent cars. Most car rental places will not rent to people under 25. If they do, they tend to charge much higher rates. The reason why, even if you individually are just fine and are a perfectly safe driver and aren't going to do anything wrong, they know that on average, they don't tend to make money renting to people under 25. They tend to be more likely to damage the cars, whether it's through just kind of making messes, whether it's through wrecking cars. They have that data based on the correlation between age and how much they wind up paying to get those cars back up and running. So that's one of the reasons why you get locked out of stuff like that. And they have determined using prediction and using past data that it's not a good business model for them. It's not likely to make them money, even though it can be frustrating. So we use prediction all the time. We use statistics essentially to tell the future, to figure out what's going to happen before it happens. Again, it's imperfect, but again, on average, it tends to be pretty accurate, and the stronger the correlation is, the more accurate it becomes. So here are some basic terms before we wrap things up for this video. First, when we talk about regression, we generally are talking about things in terms of predictor and criterion variables. So the predictor variable is the one that you expect to know, and you're going to use it to predict scores on the other variable. This is usually set as our x variable. So we might call our x a predictor variable. By the way, we have just one module left for me to accidentally knock this over while I'm writing on it. I promise I will keep those videos up and I won't start over, so you can witness that. But it hasn't happened yet, so keep your fingers crossed. So generally, x is the predictor variable. We expect to know scores on x, and we expect to use it to predict scores on y, which is called the criterion variable. Now, some people will call that the predicted variable. That's also totally valid, but criterion is just the term that we use in the book and in this class. So, depending on what data you have and what you're interested in predicting, sometimes the exact same variable can be a predictor in one situation and a criterion in another. It's not like they're locked into one category or the other. It depends what you're trying to do and what information you expect to have. So for example, you might ask, does media consumption predict school attendance? Well, in this case, you're going to measure media consumption. You're going to use it to predict school attendance, so attendance would be your y variable or your criterion. Then you might come back and follow up on another question. Does school attendance predict criminal convictions as an adult? Now, attendance is the predictor. It's the one that you expect to know and you're going to use to make predictions on that second variable, which is now criminal convictions. Criminal convictions is now your criterion. So exact same variable, but based on what you expect to know and what you are trying to predict, it can play either role in our regression framework. So we're going to talk about predictors and criterion quite a bit. A regression model is a prediction model. It's a model used to make predictions. The most common type of prediction model is what's called linear regression. It's more accurately called simple linear regression, like we have labeled up there. It's designed for simple linear relationships with one predictor and one criterion. There are lots and lots and lots and lots of different prediction models that are out there. The goal of all those models is to make as accurate a prediction as possible. So there are lots of ways to try to get at that idea. Then the more complex the question you're asking is, the more complex the models tend to be. But a regression analysis at its heart creates that line of best fit that sums up how x and y are related. And then we use that line. You can do it visually by just placing a point on that line, or you can do it mathematically, as we'll learn how to do later, to make predictions about y scores on that criterion variable that aren't yet known. So for example, maybe my x and y are the number of classes attended in final grade. Maybe I want to predict your final grade scores by number of classes attended. Of course, in an online class, that would be more like number of videos viewed. But I could still make that prediction if I know the correlation between those variables. I can make the prediction even before you have a final grade. And the stronger the correlation is, the more accurate it will be. So that's some of the basics of making predictions, some basic terminology, that sort of thing. Next up, we are going to dive into the linear regression model and break down some of the basic components of it and how it works. I'll see you there.